Hey guys, it's Miss Suzanne, and today we're going to talk about prime factorization. You can write any number, any composite number as a product of prime factors. So I'm going to show you how to do it. So always remember you need to think about factor trees when we are talking about prime factorization. All right, so first, here's what we do. Okay, like I said, composite numbers can be shown as the product of prime numbers. To find the prime factorization of a number, first you have to write the number, then choose a factor pair, but do not use 1 times that number. And then 3, if the factor is prime, circle it. If it's not, you keep going. So here we have 12. We're going to find the prime factorization of 12. So I do step 1, which is write the number. Then I have to think what times what is 12, but I cannot say 1 times 12. So I'm going to start with 3 times 4 because I like to use the larger factors first. So now that was step 2. Now I'm at step 3. So if the factor is prime, I'm going to circle it. If it's not, I keep going. So 3 is prime because it only has 2 factors, 3 in itself. So I circle it. So that tells me to stop. But 4 is not prime. So that tells me I have to keep going. And when I say 2 times 2, that is equal to 4. 2 is prime. So I circle both of them, okay? And so now I have circles at the end of my branches so I can stop, okay? So to get the answer, what we say is 12 equals. I list all the prime factors in order from least to greatest. So there are 2 2's, so I say 2 times 2 times 3. And think about it, 2 times 2 is 4. 4 times 3 is 12, and so I know I'm correct. But I want to write it in simplest form, so that's going to be 2 to the second power times 3, because I want to use exponents at the very end if I can. So the prime factorization of 12 is 2 to the second power times 3. Okay, so let's do another one. So let's say that we have 54. So the first thing I have to do is I have to figure out what times what equals 54, and I cannot use 1. So 54 is even, so I could say 2. 54, 5 plus 4 equals 9. So 3 can divide 54, but I'm not going to use 3 today either. But I do know that 6 times 9 equals 54, because again, I want to use the larger factors first. Okay, looking at that, 6 is not prime. So I could say 2 times 3 is 6. So now I'm looking at my factors. 2 is prime and 3 is prime. So I'm done on that side of my factor tree. So now I go back over here to 9. And 3 times 3 is 9. And so both of them are prime, so I circle them. So now that I have circles all at the end, I'm ready to write my answer, which would be 54 equals 2 times 3 times 3 times 3, which would equal 2 times 3 to the third power, because there are 1, 2, 3 threes. Okay, so if you want to, pause the video and do 90, do the prime factorization of 90. All right, so let's take a look. There are a lot of things that you could have said for 90. You could have said 5 times something, 2 times something, but I'm just going to go with the 9 times 10. Okay, so I'm going to start with 9. I know 9 is a composite number, so I have to keep going. So I say 3 times 3, which both of those are prime, so I can circle them. Now I can't forget about the 10, so I come back over here, and that's 2 times 5, Both of those are prime. So the prime factorization of 90 equals 2, because I want to list them in order from least to greatest, times 3 times 3 times 5. Okay, so now let's write it with exponents. So that's going to be 2 times 3 to the second power times 5. Because if you think about it, 3 to the second power is 9, and 9 times 5 is 45. And then 2 times 45 equals 90, and that's what we started with, so we know that we're correct. Okay? All right, so next we're going to do a couple of more. So if you want, you can pause the video and try them out and see if you get the right answer. All right, so here I have 99. I could start with 3, but I want to start with 9 times 11 because I know 11 is a prime number, so I can go ahead and circle it. So now I go to 9, and 3 times 3 is 9. I have everything is circled, so the prime factorization of 99 equals 3 times 11, which equals 3 to the second power times 11. Okay, now let's see what you did on 36. Okay, again, we could say a lot for 36. I could say 4 times 9, I could say 3 times 12, I could say 6 times 6. So there were a lot of things I could have said. So before you go erase, let's check your answer. So let's just say you said 4 times 9. Okay, 4 times 9, both of those are composite, so I have to keep going. So 2 times 2 is 4, both of those are prime, so I can stop. And then 3 times 3 is 9, and both of them are prime, so I can stop. So 36 equals 2 times 2 times 3 times 3. Because 2 times 2 is 4, 3 times 3 is 9. So that's 2 to the second power times 3 to the second power. So that is the prime factorization of 36. So even if you had started, let's see what would have happened if I had started with 36. I mean, with 6 times 6. So let's look at this. Let's say I had 36. If you had done 6 times 6, we still would get the same answer. Because 6 times 6, all right, 6 is 2 times 3. 2 and 3 are prime, and then I have 2 times 3. 2 and 3 in prime, so that would equal 2 times 2 times 3 times 3, which is 2 to the second power times 3 to the second power. Oops, not third power. Second power. So, and that's exactly what we got over there. Okay? And even if I had done this, let's say that I had said, what if I had said 3 times 12? Well, 3 is prime, and then I could have said 3 times 4. That 3 is prime, and then 2 times 2. I still get 2 to the second power, because I have 2 2's, times 3 to the second power. So no matter which way you did it, you would still get the same answer. All right, guys, thanks for watching, and have a happy new year. See you soon. Bye.